Hello everybody, this is Amika Gorty here, and you're watching Mickey STEM. So today I'm going to be doing a math video that is based on a very important topic in math called number theory. So number theory is just basically manipulation of the numbers. And number theory can be useful in almost everyday life like physics, engineering, and technology, and so on. So today we're going to be solving some problems that either test your knowledge or gains your knowledge. So these problems are from the 2016 AMC 8, so if you guys search that up, you might be able to find some problems also in this question paper. So let's get started on the questions. So the first, I'm not going to be writing down the question on the screen, so if you want to take any notes, please do. So the question is, the number n is a two-digit number, and the two conditions is when n is divided by 9, the remainder is 1. And when n is divided by 10, the remainder is 3. What is the remainder when n is divided by 11? So I'll go ahead and, that's too much, write n. Oops. Why isn't this working? So I'm just going to go ahead and write n. So when n is divided by 9, the remainder is 1. And when n is divided by 10, the remainder is 3. So let's take a look at the second condition. When n is divided by 10, the remainder is 3. That means when n is a multiple, if n is 3 more than a multiple of 10. So if I take the number 33 and I divide by 10, I'll get 3 with the remainder of 3. So that works. So this is the type of number that we're looking for, and that clearly means that the units digit of n must be 3. So I'm going to go ahead and put down an important piece of information. N is equal to a3, where a is not some number times 3, a is just the tens digit of n. So let's go ahead and check out the second condition. When n is divided by 9, the remainder is 1. That means I can go ahead and write this. A3 is equal to 1 plus a multiple of 9. A multiple of 9 is just 9 times some number, and I'm going to represent that number as x. So x right now is not important. No, we are not trying to solve for x. We are trying to solve for a. Because a is going to complete the two-digit number, and then we're going to be able to find n. So since we know that 1 plus 9 times some number is equal to a3, that means we can also say that 9 times some number must be some number with a units digit of 2. Only then we add 1 and get a units digit of 3. So that can already set our brain thinking like, okay, so 9 times a multiple of 9 must have a units digit as 2. And instead of thinking about all the multiples, what we can go ahead and do is just think about the numbers that we have. A 9 times some number is going to be ending up as 2, a units digit of 2. So 9 times 1 is 9, and since we need 2 digits, it's not going to work. 9 times 2 is 18, that's not going to work. 9 times 3 is 27, nope. 9 times 4 is 36, nope. 9 times 5 is 45, not going to work. 9 times 6 is 54, also not going to work. 9 times 7 is 63, nope. 9 times 8 is 72. And there we go. We've got a number which the units digit is 72. So we can go ahead and write 72. Oops. 72 is equal to 9 times 8. So obviously we know that x is equal to 8, but that's not very important right now. We see that a is equal to 7, and that's the more important part. So now that we have the number 72, we know that the actual n is 73 because a3, right? We need a3. So if a is equal to 7, then we have n is equal to 73. Now, one very important thing that before you jump into conclusions, especially in math, don't jump into conclusions. Make sure that you do recheck your work. So we found one possibility is n is equal to 73, but we're not 100% sure that it satisfies our conditions. So let's go back and check that out. So we know that when n is divided by 9, the remainder is 1. So let me go ahead and divide this by 9, 8, and the remainder is 1. So we know that the first condition gets satisfied. Let's go ahead and do this for 10 as well. We know that it's 7, and the remainder is 3. So this condition gets satisfied as well. So we solve for n. That's what the question wanted, right? Actually, no. Let's go ahead and see what the question is actually asking for. The question is asking, what is the remainder when n is divided by 11? Now that's great that we found n, but we haven't solved the whole problem yet. We still need to find what is the remainder when n is divided by 11. So now that's not that hard. We can go ahead and divide 73 divided by 11. Well, we can go up 6, which is 66, and the remainder is 7. So, and that is indeed the correct answer. The remainder is 7. So we solved, but this is basically number theory. We solved using multiples, the basic logic, basic foundation of all the numbers. So now if you don't know a lot about multiples, then I do suggest that you go learn about it because multiples is extremely essential in number theory and math in general. So let's go on and move to the next problem. Okay, so the next problem is not fully about number theory, but I also do want to see if you guys know about this, and if you guys don't, you guys will learn something very important. So I'm going to write down a couple of numbers, and we're going to try to find which number is not a perfect square. Now, you guys might be thinking, well, that's easy. If I know perfect squares, well, we'll see once you find this out. 1 to the power 2016. And we have 2 to the power 2017. We have 3 to the power 2018. 4 to the power 2019. Oh, that was pretty bad. And we have 5 to the power 2020. All right, so what we need to find is determine which is not a perfect square. Very important, not a perfect square. Not a perfect square. Well, obviously, I'm not going to be multiplying 5 2020 times. That's impossible. We can't do that. So we're going to use a little bit of our number sense, and we're going to be able to find which one is not a perfect square. So first things first, I'm going to use a little bit of an elimination trick here. I don't know if you guys know this, but 1 is always a perfect square. It doesn't matter. 1 to the power 1 billion is still 1. So it's a perfect square. And also, another quick note, square root of 1 is always 1. Just saying, square root of 1 is not some really tiny decimal. It's just 1. So, 1 to the power 2016, well, we can go ahead and cross that off. I'm just going to go ahead and erase it so you don't keep considering it. So, we have possibilities of 2 to the power 2017, 3 to the power 2018, 4 to the power 2019, and 5 to the power 2020. We've got 4 people running up for the correct answer. So, how do we determine who is a lie? Well, I can use some of my knowledge and say that any number, odd or even, any number to the even exponent, any number to the power of an even exponent is always going to be a perfect square. Why? Because if you can see, we can write an even exponent 2 times some number. So you can write, you can write 3 squared times to the power something, where you multiply the two exponents and you'll get this number. So we know that any number to the power even exponent is a perfect square. And we have 3 to the power 2018 and 5 to the power 2020. So we know that those people are also out of the running. Yay, now we have definitely shortlisted this. But we've run into a small problem here. Well, we have 2 to the power 2017 and 4 to the power 2019. Well, those two numbers have odd exponents. So how do we exactly figure out which one is not a perfect square? Well, let's use some important knowledge of exponents. How can I rewrite either of these? Well, 2 to the power 2017 is basically at its most simplest form, I guess, but 4 isn't. So I can rewrite this as 2 squared. Well, that's 2 squared to the power 2019. Well, that's kind of funny because I have parentheses around 2 squared, so I would have to compute 2 squared first, which is 4. 4 to the power 2019 is the same thing I wrote over here. So, well, another important exponentials, hopefully you guys know this, is that when I have like this kind of format, I can do 2 times 2019 times 2. And 2019 times 2 is 4038. So I can rewrite that as, I'm just going to make sure that it's correct. Yes, indeed it is correct. 4038. And in fact, you don't really need to do this if you don't want to. You can just know that 2 times 2019 is always going to be an even number. We all know that. So, well, obviously we see, my 8 was awful. We clearly see that 2 to the power 2017 and 2 to the power 4038, we can easily determine which one is a perfect square and which one is not. We have 2 to the power 4038, aka 4 to the power 2019 is out of the running now. We can see that this is not going to work. We have our finalist, which is 2 to the power 2017. That is the winner. Yes, so 2 to the power 2017 is not a perfect square, and we have solved the problem. This is correct. Let's move on to the next problem. The next problem is a little bit challenging, and it is one of the last problems in the question paper, so it might be a little hard. And this requires a lot of knowledge of divisibility tests and multiples. So if you do not know about that, go ahead and learn about all the divisibility tests and come right back and you'll understand the problem. Alright, so the digits 1, 2, 3, 4, and 5 are each used once to write a 5-digit number PQRST. The 3-digit number PQR is divisible by 4, and the 3-digit number QRS is divisible by 5, and the 3-digit number RST is divisible by 3. What is P? So let me just go ahead and write PQRST. PQRST. Yes, I know I write awfully slow. So we've got only a couple numbers. We've got 1, 2, 3, 4, and 5. And remember, they're only used once. They can be rearranged in any form, any way in the form PQRST. So the 3-digit number PQR, which means we have the first one, PQR, is divisible by 4. It must be divisible by 4. And we have the 3-digit number QRS. Oh, that's awful. QRS is divisible by 5. Must be divisible by 5. and the 3-digit number RST is divisible by 3. Let me go ahead and do a yellow. I haven't used yellow. RST, last one, is divisible by 3. So, learn your divisibility rules. If you don't know what they are, learn the divisibility rules for 3, 4, and 5, and hopefully, very much hopefully, you guys know what it is for 2. Alright, so 5 is very easy. So I'm going to go ahead and just go directly to the 5, QRS part, middle numbers. QRS must be divisible by 5. So that means the last digit, S in this case, must be either a 0 or a 5. And since 0 is not any of our options, S must be 5. So I'll go ahead and write that. P, Q, R, 5T. PQR 5T. So that's a big step forward. And let's go back to the first one. The digit number PQR is divisible by 4. That means PQR must be even. So R must be 4 or 2 because, 4 must be even. So we've got that down. R must be, just really quickly write it. Simple 4. R is equal to 2 or 4. Just a quick note, just to take a look there. There we go. So let's go to the other one. RST, the last numbers, must be divisible by 3. So we have R5T is divisible by 3. Let me go ahead and push out the divisibility rule for 3, which is going to be the sum of the digits in the number must also be divisible by 3. So we see that already 5 is there. So R plus 5 plus T must be a multiple of 3. So since we already have 5, we can say what's the next multiple of 3? Well, 6. 6 is a multiple of 3, but for 6, you would only need a 1 or 0. And we don't have 0, and we only have 1, so what's the other one going to be? So 6 is not a possibility. So 9 is the next multiple of 3. So R plus, since we already have 5, we have 4. Well, you need R plus T must equal 4. And the only possibility is 1 and 3 or 2 and 2. And since the numbers are only used once, you only have 1 and 3. But here's the big deal. We know that R must be 2 or 4. So if R, either of them, is 1 or 3, that's not going to satisfy the other condition. So we know that 9 can't be the number. So the next multiple is 12. 12 is, well, we have 7 left. We can do 4 and 3, or 2 and 5. But since 5 is already occupied, we need 4 and 3. And since 3 obviously cannot be R, R must be 4. So we can go ahead and take this out, and let me go back to that color, and put a 4 in here. And since we probably already know what T is, let me go ahead and take the T out, and I'll put a 3 in here. So, well, we can also cross out these numbers since we've already used them. We can't use them again. We have 1 and 2, or 2 and 1 for P and Q. I also do not need this anymore. Thank you very much. So, what can we do to test? Well, we can test it out. Let's say we have 2 possibilities. I'm just going to go ahead and erase this because I would like some space, please. Yes. I have 1, 2, 4, 5, and 3, or 2, 1, 4, 5, and 3. Well, how do we know which one is the right number? Well, here's, let's take a look at the first 3 numbers. PQRS. Oh, no, sorry, PQR, not PQRS, PQR. Well, we know PQR must be divisible by 4. let me give you another quick tip for the divisibility rule for 4. The number should not only be even, but here's another quick tip. The last two numbers of the number must be divisible by 4. So what I mean is, let's say I have the number 316. 16 is divisible by 4, so 316 is also divisible by 4. That's exactly what I mean. So let's take a look at 124 and 214. Well, 124, we know that 24 is divisible by 4, so I know that the whole number is divisible by 4. What about 214? Well, 14 is not divisible by 4, so we know that this number is not divisible by 4. So we have accomplished our goal. We see that 12453 is the number PQRST. Again, we have used our knowledge of divisibility rules and number sense. We have eliminated all other possibilities, and this is our finalist, our winner. 1, 2, 4, 5, and 3. There we go. 1, 2, 4, 5, 3. I just love this pink color. Okay, guys. Well, working through these problems has been very cool. I hope you guys learned a lot or tested your knowledge of number theory. It's been really fun. Hopefully you guys liked this video, enjoyed solving number theory problems. Number theory is personally my favorite math topic because you get to manipulate so many different ways and use your number sense as well. So I hope you guys liked this video. Thank you guys so much for watching, and please do like or subscribe, and I will see you later.